When analyzing a graph, there are two particular features that can be very useful for this analysis. The slope is one of them, and the area is another. In one of the first labs that we looked at, the tumble buggy lab, what we saw was a vehicle that moves with a constant velocity. So the graph that we looked at was the position versus time graph, and what we saw was the slope was linear for the position versus time. There was an even amount of position, change in position, that was ticked off per second. So if we look at this particular example, we go to a time of 10 seconds and we see the position is changed by 80 meters. So we look at the slope for that and we have 8 meters per second. And from this we defined what the velocity was. From here we can go and graph the velocity versus time curve. And going to 10 seconds again, we use this slope to show a constant velocity of 8 meters per second. So in an example like this, we start with position versus time and we generate the velocity versus time graph. But we can go the opposite direction. Taking the velocity versus time graph, instead of taking a slope, because the slope isn't particularly interesting, the slope is 0, if we look at the area under the graph, we can gather some more interesting information. So we select this entire region out to 10 seconds, from 0 to 10 seconds, up to 8 meters per second. And when we take this area, we see that our area is our length times our width. And the length we can specify as delta t from 0 to 10 seconds, and as a delta v, or just v, from 0 to 8 meters per second. And we multiply the two of those together, we have 80 meters, which gets us back to our final position that we found from the original position versus time graph. So what this tells us is that the area under a velocity versus time graph is the displacement, delta x, the total change in position from your starting position to your final position. This doesn't give you any information about where you started, whether you started at a position of 20 meters or started at a position of 40 meters. It just says that you've gone from some starting position and you've added 80 meters to that. So this is going to be a particularly valuable way to take information about velocity and retrieve information about the final position of an object.